Hello, everybody. Welcome on this Tuesday tap room where we're going to talk about virtualized shared storage for Microsoft Hyper-V, and also I will show a tiny bit of VMware NFS share, and all this will look kind of similar to a step-by-step guidance. This is not going to be like the exact step-by-step. I will miss something, the one which I think is not as important as some other stuff. And just before we start, could you please tell me in the question box, can you hear me well? Okay, great guys. Thank you very much. So, yep, I think we can move on. So, this is the banner you all saw. It says once again that we're going to be talking about StarWind Virtualized 3, and we'll be creating a share volume where you can place your virtual machines in future or anything you'd like to place there and make it a share SMB3 and a bit of NFS, which is used for VMware. This is me. I'm a solutions engineer at StarWind Software Incorporated. I'm almost a year with this company, and I very enjoy working here. I like configuring stuff, troubleshooting stuff. Uh, I like the I like people who are around me in the office, and I just like everything here. Think we can move on. Okay, and this is like a quick overview of what are we going to talk about here. I would like to I would like to more I would like to talk more precisely about the StarWind Management Console and about its device creation, since I think it is a very important part because we have many settings in that advanced option, and I would like to discuss them all because just because I'd like to do so. The second thing is the configuration for the SMB3 share and the NFS share, which is why we are all here about. And the last thing is questions and answers. I would gladly answer to your questions, and that would be it. So we will start from our host. Here it is. This is our Hyper-V host, and we will move on to those settings later. You're connecting to the StarWind Management Console if you're not connected, and then you launch it and you see a couple of servers here. And this is, by the way, the old server. This one over here. So I just press a remove. Well, let's imagine this is a new fresh console which you just installed, and you click onto add server. You can type in the host name or the IP address anyway. StarWind support HV1. This is our second StarWind host over here. It has a couple of devices created already inside it, and I think we will have to remove one of them. Yeah, we have no free space at all. So actually, I think we can go ahead like this. So over here, you have two choices. One of them is Add Device and Add Device Advanced. Add Device is a wizard which allows you to add a StarWind device with default settings. This one I personally don't like to use because I know a bit more about StarWind, and those custom settings are pretty important to me, so I always choose this one, and I suggest you guys choosing this one as well. So you press this advanced wizard, and over here you have a choice of 3 devices. This is a tape device, a virtual tape library, and optical disk drive, which we're not going to be talking about them today. And the one we're interested in is hard disk device, virtual hard disk device. Yeah, and over here it says that over here we have an option to add in a virtual disk, which will create a image file on our physical storage disk or RAID or anything. This is a physical disk, which is a disk bridge. It just imports the whole LUN over the iSCSI or something else. And the RAM disk, this is a disk which is made like a small disk which is made inside of your RAM memory and can be used. This feature is now in development, and we also have HA RAM disks in our test labs, and right now they're doing a great job, and these RAM disks, they might be very useful for maybe some temp basis. For example, if you're running a SQL server, and SQL servers, they usually have temp basis, and RAM disk is good for those because they are temp, and so they do not contain some extremely important data, because as we all know, if for some reason hosts get rebooted, the random access memory loses all the data inside of it. So this is a pretty risky one. This is extremely fast storage, but a risky storage. This one is the safest, so we'll go with it. Actually, there are no significant difference between those, but people are used to virtual disk and they like it more, I don't know. So we'll stick with this one. Over here you can specify the path, and we will specify it to our E drive over here. And let's name it a tap room device. Let's give it a 1 meg size because there is no memory. And yeah, over here you can specify the size, and you can also use existing file if you have one. And also in some cases it is important to have the opportunity to mount that drive in a read-only mode, and it is possible here, but we don't need it now. We need to create a new device. So over here you say create new file, you set the size, and then we go to one of the most interesting settings that I enjoy the most. So over here there is a sector size. The sector size is really important because in case of Hyper-V, it does a good performance boost, really good. So this 4096 sector size, it is Hyper-V native. So if you are planning to use this or any other device that you'll be creating only for Hyper-V, you set this amount of sectors of bytes per sector size. But there are tricks, because for example for Xen or for VMware, or even using storage spaces on 496 won't work. So as a default, we decided to set the amount as 512, which works everywhere. But in case if you are running Hyper-V and this LUN is for Hyper-V only, you choose this one and you get a great boost. We'll stick with that one because it's a 1 meg device. We're not planning on running any production on it, obviously, or like almost nothing. So this amount is completely fine to me, and I think this one might be connected to VMware one day, so we'll stick with this size. Over here, there's also another choice of thick provisioned and thin provisioned. And actually this thin provisioned, it's quite a weird name, and we'll move to that a bit later. So thick provisioned is just a casual standard StarWind device which you block, most of you probably maybe like the most part, yeah. Just used to see in your StarWind management console as a standard LAN, which is then connected to your any host, and then it is just a standard LAN which has no boosts by itself, but you know, like some things that are straightforward and simple, they're the best. And I personally enjoy thick provision drives more than thin provision, but I would say this is just a preference. Anybody can choose any type. Well, the second type has upsides and downsides. The upside of it is that actually it is not a thin provision device. It is an LSFS device. This is the way we call it. It is a log structured file system. So this LSFS device was initially designed for slow spindle drives. Those who have 7,200 RPM, or maybe slower. Some people do use slower ones, but I think 700, 2000 for the LSFS is the best speed. And especially if you get a couple of those drives, like 3 or more, you can combine them into a RAID 5 or RAID 6, and this is what this device was made for, because the point of it is that it provides you with a great write performance, write boost speed. I mean write speed boost, because it works this way. So you have many VMs running on your production system. Those VMs, they generate some amount of operations like whole time, even if they are not doing any production things, even if they are not like doing some processes, but just running the OS, it generates a lot of writes and a lot of reads. The point of this LSFS device is that it takes many small random blocks of data, combines them into one huge sequential block, and then performs a write. As we all know, sequential writes are much better than random ones, and they they get processed faster. And this is how we get that performance boost, especially for the write operations. Also, before I mentioned, this device was designed for RAID 5 and RAID 6, and as we all know, RAID 5 and 6 has extremely good read performance, read speed. So we actually decided to not do anything with it since it's good enough, and we focused on write performance, and this is what we got. As for the downside of this device, there is only one of it, and that downside is that it actually eats up 3 times more space, and here the confusion comes. You will say, well, if it's called thin provisioned, then I can create a 100 terabyte drive and place a 1 gig file on it, and on my disk, it will eat up only 1 gig because this is how thin provision devices work. But unfortunately not. This is not how it works here, and this thin provision will be future renamed into LSFS because we decided that it's not actually thin provisioned. It has some things, some similarities with it, but it's not it. So if you place a 1 gigabyte device on this LSFS drive, it will grow into 3 gigabyte file. Because the way it is designed, it is a log structured file system, and each write operation on it gets logged. And that log, it eats up that space. And the point of this log is that sometime in future, we will make it able to restore from those system snapshots. This is how we call it. And I think that's great, and that would be an awesome feature. Also, there is another, well, I was saying that it will be renamed and it has some similarities to thin provision drives. And another thing about it is when you have many things inside your LSFS device, when the workload is not high, it's somewhere between middle and low, LSFS device turns on the background scrubber, and this scrubber, inside our company we call it this way, but I mean this is just a a creature which cleans up your files. And this is how it works. So if you have two identical files written on this drive, it deletes one of them and provides that second copy of it a link to initial written one. And in future, so your LSFS device, it will grow 3 times more, and then after some time is passed, it will grow back to a small size. But unfortunately, this will only come in future, and right now this device just grows 3 times more, and that scrubber doesn't have really enough time to clean it all up. And many people are using LSFS for extremely intensive workloads, and those extremely intensive workloads, they generate huge amount of snapshots, and then that device grows and grows and grows, and that's it. Over here you might notice that there is a options button, and this options button says about the deduplication, and LSFS has the inline deduplication. So when many writes or reads, I mean writes of course, because not reads, when many write operations come in and the LSFS device sees that there is that data already on the drive, and it just doesn't get written, and it provides the write operation source with a link to this physical file there. So you can enable it or disable it. As I said, I myself prefer thick provision drives, and we'll stick to those. When we go next, over here there is a caching parameters. There are two modes that we can configure our cache in, and one of them is writeback, another one is write through. Writeback is designed to increase write performance and read performance simultaneously, and write through is designed to increase only read performance. So if you have intensive read workload, use write through mode. If you have intensive read and write workload, or even just write workload, use writeback. Also, you can set any amount. This L2 cache, it uses random access memory for it. So you set over here some amount of it, the one that you have free, but we also have recommendations for that size. And as for L1 cache, we recommend to set the amount in next proportion. So if you have a 1 terabyte StarWind device, we recommend setting L2 cache to 1 gigabyte size. Since we have a very small device, we actually will not use L1 cache because I don't think it will make any sense at all. This is L2 cache. L2 cache works completely the same way and the same algorithms and does the same thing as L2 cache, but uses another resource for it. It uses solid state drives, and that SSDs as well can be configured as a write-through cache or write-back cache. Also over here you can set the amount that set the L2 cache size, the one that you want to use, and our recommendations as for L2 cache is that it should be 10% out of whole storage. So if you have a 1 terabyte device, should be a 100 gigs of L2 cache per your drive. Unfortunately, we do not have SSDs in this configuration, so we will not set it because there's nowhere to set it. Finally, we get to this point over here. There is a chance to attach your device to existing target, keep it unassigned, or create a new one. Target is a thing that we need to we need a target to connect your device somewhere, and that target is what we're going to see in the iSCSI initiator. We are asking it to create a new target. We're giving it a name. We can customize target name, but I always prefer leaving it as a default, and we allow multiple iSCSI connections to this target. Over here, we've reached to creation. We created it, and it is non-active. And I know why. It is non-active because there is no space for it. So we'll just remove this device here. Remove. Also, we'll remove this one. And create a new one. I'll go faster with this one. Also, yep, we have to this device got removed, right? Let's look on the second host. Yep, over here. Just a second. Okay. I'm sorry. It looks like I missed a bit of space. So let's get back to the server we were on and just configure a device on different LUN. Yeah, let's make it on C drive. Let's call it tap room device. Let's set it to 10 gigs and just go what? Okay. I'm very sorry. This was pretty unexpected to me. So here we have this device and let's move on configuring the replication for it. So over here we choose a synchronous two-way replication. This is the active one, the one we have allowed in the free version. We type in the host name or its IP address. We click next and we choose create a new partner device since we don't have an existing one. It gives it a name. I honestly really don't like those names, so I will give it the same name as we had. And here you choose the iSCSI connections as a heartbeat channel and the synchronization for StarWind. The synchronization will synchronize your data and these devices. So over here for sync, we are using 30 and 40. So we're setting it this way, and for the iSCSI, obviously we're using these two. You set that, you go next, and then you create the replication. Okay, after the replication is created, we have to wait for it to synchronize. This will go quick. Just, oh, since we have 1 minute, if anybody has a question, a quick question about what we were talking here, I would gladly answer to it. Okay, there is a good question about writeback caching. So how is writeback cache consistently maintained when a server falls? The thing is that we have StarWind devices synchronizing with each other, and cache is also synchronized between two devices. So in case if one server falls, the second device keeps working with that, with the storage and with the device as well. And then when the second server comes back online, the cache and storage, they get replicated. So that's pretty it. There's another quick questions about the webinar. Yes, it is recorded and it will be posted later on the site, on the website. Okay, this device is synchronized. I will answer everybody's questions at the end, and I think we can move on. After we've created that device, we obviously have to connect it somewhere to see it and to have the access to it. And we are using iSCSI Initiator for that one. To see all those targets listed here, you need to open Discovery and discover your portals. This one is the local IP address. Yep. So this one is the partner one and this one is the local one. Where here I set to the refresh and we have our device over here, the newly created one. This is the local one, I believe. No, this is the partner one because this one's name is local, so it is local. We will use a local IP address to connect it, and this one is partner, and we will connect it through our iSCSI interfaces. It's 30 and 40, I believe. I might be wrong, but I don't think so. 30, 40, here it is. So I'll quickly double check in case if I'm wrong, but I think, oh, it's 10. Very sorry. In case if you've configured wrong connections, you just go and add in the correct ones and remove the old ones afterwards. 2020, 2010. Yep, there they are. Okay, and these are the wrong ones, and we just disconnect those. Okay, after that, we open our disk management to see the device that we've created over here, and we bring it up online. After we do that, we initialize disk as a Jibity partition. This is what our best practices say, and I like following them. After that, we create a new simple volume. We give it a whatever drive, and let's give it the same name as we did in StarWind Management Console. It is formatting. There it is. To make it HA, well, it is HA in StarWind, but our second server still has no access to that. For some reason our file server just failed because maybe because I removed. Just a second. We have to refresh this to see our newly created device. over here. Yep, and this one is the local one this time because we are now on the first one, and this one is the partner. I won't make the same mistake second time, so this time we'll configure everything with the right IP addresses. And here, yeah, we choose the 20 and 2020. Great. We connected this device, and to see it in the disk management, over here, there it is. We just have to bring it up online, and here it is. So after we have created this device, we actually need a file server. It should start now. And yeah, over here we need to add a drive, the one that we've created. We add it over here, and there we see it. This cluster disk 1. Let's rename it. We go into properties and give it this name. Also, to create a file share, we afterwards need to assign this disk to our file server. Yep, it is assigned to our file server. And after that, we add a file share. We need a quick SMB share. Over here, it doesn't want to show us the one we have, but let's see what it has here. It has the NFS, and it has this drive here, storage. Actually, just one second. It may be configured as a file share already. Let's try to connect to it. Two slashes, StarWind sup, how was it? So over here you type in the name of your HPFS, the name of your file server. Then you go /d bugs. There we go. Well, we don't have access to it because there is something wrong with our server, with the file server. But another good thing about it is that our NFS share is alive over here. Yep, that was my mistake when I removed that NFS device. Let's try bringing him back. I think troubleshooting will be interesting to all of you. But that's not actually troubleshooting, that's just setting this device here, the one we had before, the NFS SWSDK file. Go next, create. Yep, there we have it here on the HV1 host, and this one is on the HV1 host as well. All the connections to that device should reconnect. and we need to be able to work with it. No, it has no connections. Let's configure them then. This one over here, it's local, so we are going to be configuring it with a local connection. And there is no partner one since we didn't create it. We didn't create a replication for it. So we brought this share online, and our file server started running as well. So I'm sorry for removing that device, guys. Wasted a bit of time, but this might be interesting for anybody in case you remove your StarWind device accidentally, something goes wrong, you just re-add it, you re-establish the connection, everything is fine. After this is done, we still need to configure this as a file share. Over here, we have it. If we go into its, no, it is not configured as a file share yet. So we go into add a file share. And we actually had to see that, just a second. So over here we have two shares. And if we go into disks, this disk belongs to the, okay, great. It should be actually a file share already. Yeah, or yep, the policies are correct. And this is our name. But it also should have a, yep, change drive letter to G, for example. Okay, this has G now. And if we go here, we can try connecting to it. No, not yet. Okay. That is very strange because it has to appear there. We had this issue some time ago, but unable to retrieve data required. Okay, I believe I remember the solution to this. So if we go into another server and do the same thing here, yeah, there it is. So over here, this is our file share, the newly created one, since we gave it a G letter here. And to be able to access it, we have to configure rules for it. We make it continuously available. Also, over here, we customize permission, we edit, and we give it full control. And in general, this is right. This is also right. Apply. No, that's fine. Okay. Over here, this is our G share configured here. And if we try to connect to it, yep, /G, we'll be able to do so. And we can create something here, like folder, and place a file inside of it. And basically, this is how you create your file share. It's pretty easy. You might think that it was hard because I made that issue with the file server and it had troubles with setting the permissions. But anyway, it's pretty easy. And it is a bit harder to create the NFS share. Since this topic was made to, I mean, this chat room is for the Hyper-V. I won't be talking much about NFS share. I will just show you how can you create it a bit faster with the real one. I won't be creating it from the very beginning. So over here we have our mini NFS. Over here you have the remote path to it, which you will require later. You configure all the permissions here, and to make this file appear here, you just create a usual StarWind device connected locally and from partner as well as the same way we did with this device. So we are creating device, we're making it HA, wait for synchronization, connected on one side locally and to a partner node, and on second server locally and to another partner node. Basically, that is it. Then you initialize it in disk manager on one side, and then you just bring it up online on the other side, and that's it. You have a file which you then add over here. Add disk, you add it as a storage, and then you assign it to your file server, and then over here it will appear. It actually won't appear here. It will appear here as a drive. Then you right click on it, add a file share. Then you click NFS share quick. Yep, here you go next. And over here your device will be listed. After that device is listed here, you just select it and it will appear over here on the bottom as a NFS share. Then you right click on it, you set the rules, and after you allowed the access to your VMware, you open your vCenter appliance. This cluster is down because these are the hosts I'm working right now with on Hyper-V. And this is this mini NFS share connected here. So after you've configured it on a file server side, you go into this vCenter client, vSphere client, then you click onto Add Storage, Network File System. Next, you over here set the IP address of your server or the name of it or the host name. You type in the folder path. You give a name to your data store. Then you click next, and then you get your file share over here. You can place your virtual machines on it. It will fail over as it always does in any setup in StarWind, and you can enjoy your StarWind free version, especially when we do allow using it in production. So basically that is it for today, and we can move on to this slide where I would like to ask you questions, and I'll answer them. Thank you, Jen Jacob, for saying that this was helpful. I tried to make it extremely helpful. There was just a second. Yes, this will be available in a record in a couple of days. Over here, there was a question that I was talking about previously. What is the percentage recommended for L1 cache. There is actually no percentage, but there is a proportion. If you have a 1 terabyte device, we recommend setting 1 gigabyte of L1 cache in this proportion. The StarWind software can be actually loaded on almost any machine, but the only thing that we have that the StarWind is only installed on a Windows. So we cannot be installed on VMware or on Xen physically, but we can be installed inside a virtual machine, but unfortunately not in case of a free version. That's a great question. If using all-flash storage is there is no need to specify L2 cache, correct? Actually, this is arguable because if you have all-flash storage which has a certain speed, I mean each flash solid-state drive has its speed, and if you get a solid-state drive which is faster than your RAID array, then there will be sense in L2 cache. So you're making your a bit slower SSDs boosted up by a bit faster SSDs. Okay, guys, I'll give you another couple of minutes to ask me any questions. Uh, yes, the software is creating a SAN out of existing storage and a server. Uh, Bob asked a great question. Is the support for this product just in the US or is there support globally? We actually support everybody all over the world. We have 2 shifts. One shift is working European on the European time and works with almost all the world, and another shift is working for the US and Canada, only for them. So yeah, we do support all the world. What do you mean by saying what server OSs are supported? We can provide storage to any server OS, to any hypervisor, but the only thing is that StarWind can be installed only on Windows. Okay, guys, I hope I answered almost every question, and we'll move on to the last slide. Over here, I would like to thank you all. I very enjoyed talking to you guys. I was actually like kind of talking to myself, but I hope you guys listened to me, and I hope this tap room was informative. I will be waiting for you on our next tap rooms, and I hope you all come and hear some new things. I really enjoy doing this, and I just want to thank you. Tomorrow is Friday. Have a great evening on Friday, and then have a awesome weekend. And yeah, thank you all. Thank you all very much, and bye bye. Have a great each day of your life.